Okay, so a number of years ago, CDL had started into the intelligence or the monitoring systems, which have kind of been renamed into the intelligence system. Um, it's probably been about 7 or 8 years ago they came out with the vacuum sensors, limited functionality, in the system when we first started, and it really has grown over the last 7 or 8 years since the system has been put into the marketplace. We have went from just strictly monitoring, vacuum in the woods on the different main lines, monitoring temperatures, to machine controls, remote stopping and starting of pumps, remote stopping and starting of equipment, draining lines, and doing a lot of different applications. So the system really kind of has come a long ways in a short period of time, really saving a tremendous amount of labor, in the woodlots and in the sugar house. So when we look at it, where the first thing we're going to talk about is ROs. So what size ROs can be automated? We can pretty much automate any size. From a 350 gallon per hour RO unit all the way up to an 8,000 gallon per hour RO unit and everything in between. We can really pretty much automate as much or as little of that machine as possible. So, like say that the capabilities are kind of limitless as far as that goes. The questions we always get asked: does it have to be a CDL RO machine to set up the automation? No. We can go on to our competitors' machines, whether it be Lapierre, H2O, whatever the case may be. We can automate those machines as well. So, like say, it's not just strictly the CDL brand of RO that we can automate. So, do I need a CDL intelligence or monitoring system? And the answer to that is yes. You're going to need the CDL base control unit and the gateway in order to get connected into CDL system. Once you have the basic system, then you can add as much to it or as little to it as you would like. So, at that stage of the game, we can do, like say, as much or as little as you'd like to have. So if I already have a CDL monitoring system, what will I need? So basically, you would need a remote machine controller, which we have mounted on that RO machine in the back. We also have a multi-function controller on that machine. We'll run through the demonstration of the RO machine in the back of the room here just a little later on. We're going to talk about the differences between fully automated ROs and machines that have been automated, after the fact, and what the differences look like in the machines, what options are available. We're going to discuss some pricing. We're not really going to get into the schematics and the reading the wiring diagrams today. This is kind of a brief overview of what we have going on with the system. So when we talk about a CDL intelligence system, really this is kind of the pieces of the puzzle. Our control base is our small computer that handles our all of our monitoring communications with the factory and with our woodlots. We have our gateway, which allows us to communicate in different spots. So for example, at my sugar house, I have my control base in the office along with a monitor. So I can basically keep track of my monitoring system from the office. I have 3 separate woodlots. So I have 3 gateways. So instead of having to have 3 complete computers, 3 complete gateways, I can have 1 control base. And then every time I add a new woods, simply I add a gateway with internet connection, and then I can put that woods online. So I have 3 different woodlots. So I have 3 different gateways, like I said, 1 computer. And that allows me to keep track of 3 separate woodlots that are probably, 7 or 8 miles apart from each of them. And several of them are, 10 to 12 miles away from the sugar house. So that'll communicate, like I say, with the CDL monitoring system. These are put on what's called the cloud. So CDL has a cloud hosting system that the gateways are put out on a cloud so that they can be accessed over the internet. We don't have to have computer access. So this is the kind of the pieces of the puzzle we need. We need the control base and the gateway, and then, like I say, that gets us access to the CDL system. So differences between fully automated ROs and standard ROs. So when we look at the fully automated ROs, which is our HE line, which is our high efficiency ROs, the fully automated machines have a pre-programmed sequence. So say, for example, you go on your computer screen, you select, I want to concentrate to 25 bricks, say, for example. And when I concentrate to 25 bricks, I want to run it right into the feed tank for my evaporator. So basically, you answer the questions on the screen, you program in the sequence, and you hit the start button. It automatically moves all the valves, adjusts the concentration ratio, reads the level of bricks or sugar in our sap that's being concentrated, and it kind of takes care of the whole process with just one hit of a button. So it's really quite simple. There's really no risk in performing the wrong action. So like I say, if you hit the concentrate button, you want to concentrate to 25, you hit start. There's really nothing that you can do to screw it up. It'll automatically turn the valves, it'll automatically position everything and put the sap where it needs to go. Now you can run these with tank level sensors. So say for example, I want my reverse osmosis machine to run until my feed tank for my evaporator is full, and then I want it to shut off. So if you have a tank level sensor in the feed tank for your evaporator, the RO will run or concentrate until that tank gets full. When the tank reaches that full reading, that machine will desugar itself, rinse it, and then just park itself or shut itself off until you're ready to concentrate again. So when we look at the fully automated RO machines, there is a lot of different things that can be done with these machines that really further automate the process. When we look at automating a manual RO, we're a little bit different. So basically what happens is the user has to perform every action. So say, for example, on the RO machine in the back, say, for example, I wanted to have the machine rinse itself in the morning before I get to the sugar house. So you would have to manually go on to the monitoring system screen, open up the valve to drain the wash tank, close our pump wash valve, and then we would have to open up our permeate or our water tank valve. And then at that stage of the game, we could start our feed pump to rinse our machine. So when we talk about a manual RO that's getting automation put on it, instead of being fully automatic, we've got to go through and manually open and close valves, where on the fully automated machine, it kind of does it automatically for us. There is a little bit of a risk, that we perform the wrong action, we open the wrong valve, but, that's the human factor when we're running the machine manually as well. We can accidentally open a wrong valve and start, using sap to rinse our RO machine. Things like that can happen, where with a fully automated machine, we really don't have that, opportunity to happen. Like say, not fully automatic, we gotta kind of, put on every function that we have. So, and we'll kind of discuss that a little bit more as we go on. So pricing, if you have an existing RO, probably around $5,000 if you don't have any monitoring system at all to automate that RO machine. That would be buying the CDL based computer. That would be buying the gateway, to communicate via the cloud. And then that would be, machine stop, machine start, and different functions like that. Now, the more functions that we put on the RO machine, of course, naturally the price goes up. So there are a lot of different functions that can be added to these machines with automatic bricks readers, automated valves. Like for today, we're just going to simply turn on and off some pumps based on preset valves. So, like say, entry level with the monitoring system, you're going to have to spend probably around $5,000. And then, like I say, depending on the features that you want, it really kind of is going to go from there. So I'm gonna turn the lights on, and we're gonna talk about the RO machine that we automated in the back. So what we did is we just took a standard 600-gallon RO, and we we put some automation on there. So there's two things when it comes to automation that people are always asking about. One is, can I get my machine rinsed before I get to the sugar house in the morning so that it's ready to concentrate when I get there? That's one thing that people always ask for. The second thing that people always ask for, especially if you got a full-time job, hey, it would be nice if I could start my RO machine at noon when my tank is sitting full of sap. So when I get home, I've got pre-concentrated sap that I can run a second pass, put in my feed tank for my evaporator, and I can take off and run. So what we decided to do for today's demonstration is we decided to do the for lack of better terminology, the 50/50 or the pre-concentrate cycle for an RO. So for today, we're just running out of the wash tank. We got water in the wash tank. So what we did is we started our machine manually. We ran it. We documented how many turns that we had to have our permeate or our concentrate valve open and how many turns in we had to have our pressure turned in. So basically what we're going to do is we're going to set this machine up to run on a 50/50 split. So what we're going to do, say for example, is say I've got a several thousand gallon sap tank outside. I want to have pre-concentrated sap before I get home. So what I'll do is I will start the feed pump on the machine, start the turbine, and basically what I'm going to do is I'm going to take out 50%. So if I've got 2 bricks sap in the tank, I'm going to go from 2 to 4. Okay, so I'm going to take half the water out of that tank. So say for example, I've got a 5,000 gallon tank. I know the machine runs approximately 600 gallons per hour. I know that if I start at X number of hours before I get home from work, and the machine is running, I'll have that tank about half empty, which is going to basically remove half of my water from that sap. Now, if you wanted to kind of take it one step further, the other thing you could do is you could put a tank sensor in your sap tank as well, so that you could set this, and we'll go through kind of some of the automation setup. So if you wanted to say, for example, you wanted to start that RO machine up, say you're out working on the farm somewhere, whatever the case may be, start the RO machine up. You want that machine to run until that tank is half full or 50%. So what you would do is you'd set a trigger in your monitoring system that would say, I'm going to shut that machine off when my tank gets half full. Now, the opposite side of that trigger, you can set up when that tank gets up to 75%. Say I'm trucking in sap at the same time. Well, I was a little late. I found a few things in the woods I had to repair. My RO shut off because my tank got down to 50%, but I got back with the truck. I just put in another couple thousand gallons. Once my tank reaches, say, 75%, for example, it'll start that machine back up and let it run again. And it'll take it back down. It'll shut it off when it gets to 50%. So, with the addition of some more equipment, you can kind of increase the capability of this system as well. So for what I'm going to do right now is I've got everything to set to run off my laptop. Now, all of these functions can be run off your phone. And typically, like say at my place, when in the spring of the year, I don't have the RO automation because my RO for the first time in my life is big enough to keep up to my evaporator, which normally isn't the case for most people. So I can fire it up and I can run it and I can flip the switch on my evaporator kind of at the same time, and we're set to go. So at my place, what I do is I've got 3 woodlots. I've got all of our vacuum pumps set up. I can turn on and off all my vacuum pumps. For me to drive the circle to all of our woodlots is about 19 miles. So like say I can start and stop all the vacuum pumps off the phone. It's going to send me a text message if my vacuum level drops too low. The handy thing with that is, a number of years ago, we had a kind of an early spring thunderstorm come through with some wind. I got the phone on the headboard of the bed, 2:00 in the morning. My phone's going off. I got a text message. I had low vacuum in one of the woodses. So I went on there, swiped it, shut the pump off, and I worried about it the next day. So I went down there. Of course, we had a tree go over a line, broke the line apart. We were down to 5 inches of vacuum. Of course, these high vacuum pumps that we run today don't like vacuum levels that low. So we probably saved ourselves a pump by getting that warning in the middle of the night and shutting that pump off. So that worked out pretty well. The other thing we do, like say at our place, is we drain all of our pump lines. So our releasers pump up to central collection tanks we gather with trucks. So basically all of the sap is pumped through the woods to the central collection spots. And then at night when we shut our pumps off, we go on our phone, we swipe open our valves, we open up the drain valves on our releasers, we drain all of our pump lines at night so nothing freezes. Now, you can do that manually on your phone, or you can set it up to run automatically off your phone based upon temperature. There's a lot of different ways to run it. I prefer to run mine off my phone. I don't know. I don't know if I don't trust it as much or whatever the case may be, but it's simple for me to swipe it off and, just double check it. Sometimes I don't shut them off till 2 or 3 in the morning, whatever the case may be. So cameras are really easy to install. They make a very simple app. So basically when you purchase this camera, you have a CDL app on your phone. And so basically you switch your phone over to camera, you go up to the sensor, you go up to the camera, or whatever device you're trying to hook up. And basically there's going to be a QR code on every one of our sensors, every one of our multifunction controllers, Every one of our pump controllers or RO controllers will have that QR code on. So you go to the camera on your phone or the CDL app, you scan that QR code, and it automatically loads it into your system. So when you look at the installation of this system and how it works, it is super simple. Like say you scan the item in on your phone, you select, what woodlot or where you want it to go in your monitoring system, and basically it installs itself. So super easy to work with. You will need a Wi-Fi connection for the camera in the woods. So depending on how much you use the camera is really going to depend upon how much data that you're going to need out there in the woods. So I'll give you a quick example. I don't run any cameras, but I run all the rest of the stuff. I run the remote start and stops on the pumps, the draining of the valves, all of my vacuum monitors. Um, I run just a small hotspot. I get them from Straight Talk Wireless because I can put cellular service on them for 1 month at a time. So I put 2 gigabytes of data on each hotspot, and I put it on for a 3 month time frame. I think it cost me about $40 per wood, so I spend about $120 a year on internet. And then once I get past those 3 months, I just let the cell coverage or the data plan lapse, and then I don't reactivate them or fire them back up until I put data on them the next year right before sap season. So that's a quick and easy way to get your internet out to your woodlots. Like I say, there are some, we looked at, adding some hotspots through our family cell plan. And it was really, about the cheapest way to go was the Straight Talk Wireless with just some simple hotspots out in the woods. They will require a TP link, which basically converts that Bluetooth cellular or the Wi-Fi cellular, the Wi-Fi signal. It converts it to basically Ethernet or a landline, and then basically you plug it into your camera, you plug it into your gateway. So very simple. Like I say, cameras you can zoom in, zoom out, rotate, pan, reverse view. Camera prices have really come down. I think they're around $160 now, almost $180. They're really cheap compared to the first round of cameras that we had. So, like I say, works very well. So, when we talk about the different equipment that we have available for the monitoring system, so we're gonna talk about kind of some of this other stuff in detail. We have our tank level sensors, we have our cameras, like I say that we talked about. We have our IO controller, which we have one of those mounted on that machine back there. We have some automatic valves, which we can go 1.5 up to 3 inches with butterfly valves. We have some small modulating valves. We do have a new style of valve that's just come out here the last couple of weeks. We have some what we call a fast close valve, so that if we have, say, for example, a pump and a releaser fails, or if we have a mechanical releaser that, say, for example, would get a hole in the float, and all of a sudden my releaser is starting to flood out, what it'll do is once the level of liquid inside of your releaser gets so high, we have a new fast close valve that'll basically close in a matter of just a couple seconds so that we protect our vacuum pump from getting liquid back into our vacuum pump. It's like, say, we have some new valves that are coming out here just in the last, like say, in the last couple weeks. Pump safety box, we'll talk about that in a little more detail as we go on through the presentation here. Um, New trends. So, by running a monitoring system for a number of years, the enemy of our maple sap system is really ice. Okay. And at what temperature we start to freeze up that system. So I'll give you a great example of this. So when you go out into a woodlot, say in the spring of the year, it's a foggy, overcast day. It's 41 degrees, no sunshine, kind of crummy, overcast, foggy, whatever the case may be. We get a fairly good run of sap, okay? But our lines don't thaw out that quickly. So on days like that, when we have a small air leak in the system or a high velocity air leak with good vacuum, what happens is we can, at 39 degrees on an overcast day, we can freeze that system up to the point where we really limit the amount of sap that we can get out of it because we froze it up. Okay. And when we're in those, damp, overcast conditions, temperatures maybe, say, for example, 35 to 39 degrees, we can freeze that system up. It might not thaw out for a few days, so we really limit the amount of sap that we're getting. So with that being said, like say the enemy of our system is ice. So one of the things that they've been screwing around with over the last number of years here is vacuum modulation. And what vacuum modulation does, the closer that we get to our freezing point, the lower it takes our vacuum down. Okay, so say for example, we want to try and get that vacuum up as high as we possibly can. We will be running vacuum levels of say 28 inches of vacuum on our system. And when we start to cool off to say 36 degrees, 35 degrees, we may knock that vacuum down to 19 inches of vacuum. So that the closer that we get to that freezing point, those high velocity air leaks that we have, we don't freeze that system up solid at the end of the day. And there is a little there is a little bit of truth to this, so we don't have vacuum modulation at our place, but I got the next best thing. I got a sap guy that hauls sap to us that'll sit out in his pump house and look at his releaser and wait half the night for the last drip of sap to go into that releaser. Sometimes it's 2 or 3 in the morning, and he will literally sit in his pump house and wait until it is completely froze. So his sugaring operation that we buy sap from is about 4 miles north of our sugar house. So we're really not that far apart. The climate is very similar. There's nothing really between the two of us that make 2 cents a difference. So we've been shutting our vacuum pump off the last couple of years. We've been shutting things down when it hits the 33 degrees. I've been shutting our system down. And he will sit in his pump house and run that system until everything is froze right tight. So a lot of times he will give me a call. It'll be 10 o'clock in the morning. Our system will be thawed out. We'll be running sap. We'll have good vacuum on all of our lines. And he'll call me, at noon and say, oh man, I can't believe this. Our stuff's froze up rock solid yet. Well, by running that vacuum at that high level all the way down until I can't get any more liquid out of that system, any of the micro leaks that are left in his system, he's freezing his system basically solid. And he has to wait for that system to thaw completely out before he gets his vacuum back down his main line. So there is a little bit to be said about this trend of vacuum modulation, of reducing that amount of vacuum as we get closer to the freezing point. So they've been studying this over the last number of years up at Center Acer in Quebec. So Center Acer in Quebec is like our land grant university system here in the States. It would be like University of Vermont, University of New York, University of Maine. Center Acer is like the Canadian version of the land grant university. So they've got some ongoing studies, that are going on with this, and they're really looking at yields and how quickly that system opens up and allows the vacuum to get back to the very back end of the main lines, and how quickly we can get the vacuum back there once that thaw takes place. So, like I say, there is some trends with this. I know at our place, probably not for this season, but for the following season, this summer, we're going to remodel a few pump houses, and we're gonna try some modulation at our place, just to kind of dabble with it a little bit. So for those of you that are running high vacuum systems, vacuum modulation has a kind of a unique property to it. So what happens is we open up this little valve here. When we open up that valve, we send air through this vacuum regulator. So we never shut our vacuum pump off at that stage of the game. We leave our vacuum pump run all the time. So what happens is when I knock that vacuum level down to say 17 or 18 inches of vacuum, I start to bring a tremendous amount of cold, dry air through my vacuum pump. Okay, so what do we know about our vacuum pumps? The higher that we get the vacuum level in our tubing system, the closer that we get to the boiling point of liquid. Okay, so the air that we deal with when we have 28 inches of vacuum on our systems, the air that we're dealing with coming into our vacuum pumps is very moisture rich. Okay, the higher that vacuum level goes, the more moisture we're going to take back to our vacuum pump. Now, depending on the type of vacuum pump you have, some pumps do better than others as far as burning off the liquid. So if you have liquid ring vacuum pumps, yet in your woodlots, liquid ring vacuum pumps don't move a tremendous amount of air when you start getting up to 27 to 28 inches of vacuum. And what we do is we have a tendency of retaining more water in those pumps. If we're running a rotary vane pump, they run a little bit hotter. We can burn off a little bit of that moisture. So the thing with vacuum modulation is I open up this vacuum regulator and I put a large volume of cold, dry air into my vacuum pump. So if you are running into some issues at your place with liquid or water in your vacuum pumps, vacuum modulation, when that valve opens up, I run cold, dry air into that pump, say as long as it's frozen, say it's 12 hours. I run that cold, dry air into that vacuum pump. I can take a lot of that moisture out of that oil. Okay, I can dry that pump back out. Especially it's really critical on the liquid ring pumps. Liquid ring pumps, if they're running on oil, they don't like water. That sugary water or that sap that's getting into that pump's kind of hard on mechanical seals. So, like I say, just kind of keep that in mind. So, like I say, so that's kind of one of the other effects. Not only is our system thawing out quicker in the morning, but we can dry out our vacuum pumps a little bit more at night. Okay, I/O controllers. So this is that little controller that we got mounted to the RO machine. These I/O controllers can do a multitude of different things. They can turn on and off your vacuum pumps. They can open and close valves. Like say in this picture here, we're open and closing a modulating valve to knock that vacuum level down. We can run two functions on this particular controller. So for one of the wood lots that we own, it's a larger woods. We got about 6,000 taps. We have two vacuum pumps in that woods. So I have one I/O controller on the wall. Basically, it handles my start and stop of both of my vacuum pumps in that pump house. So it does work out pretty well. Tank level sensors are connected into these. Like say, this is kind of one of the big ways that the system will communicate back and forth. So, like say, this is kind of the device that we use for just about everything. So, okay, like say, dry contactors in the box. Like say, we can open and run valves. We can the butterfly valves, the stainless steel butterflies, the small ball valves, whether they're the normal on and off or they're the fast close. We run all of those out of that I/O controller as well. We do have some three-way valves, so these are especially handy when you're automating your ROs. So, say for example, I want to start my RO up and I want it to put sap back into my sap tank so that I can pre-concentrate. So what you would do with a three-way valve is you'd select that valve, you'd select your sap tank for your destination. It puts sap into your sap tank. Okay. Say on the other side of the valve, I want to pump sap up into my feed tank for my evaporator. So basically, you turn the valve to the other position. It automatically opens that valve up. It'll send it up to your it'll send it up to your feed tank for your evaporator. The nice thing with a three-way valve, it's always open. Okay, I'm going to be the first one to tell you that those little flow meters, those little plastic flow meters on the front of the RO machines, if you run manual ball valves and you leave both ball valves closed so the sap can't go anywhere, those flow meters will blow off the front of your RO machine. So we get a lot of people that, instead of buying a three-way valve, spending that little bit of extra money, they'll put in two single valves, which basically at that point they've got to manually open one and close the other to get their sap to go the right direction. Please don't do that, because sooner or later you will forget. You will have both of them closed and you will be replacing your flow meters on your RO machine. So just kind of keep that in mind. It's there's a right valve for the job, and this is definitely one of them. So if you are running a vacuum pump that has a three-phase drive or a phase converter on, where we take single-phase power in and we make three-phase power out to run a three-phase vacuum pump for variable speed, we can run them off the I/O controllers as well. The drive that we use pretty much with all of our pumps is what we call a Lindsay drive. That's the brand of frequency drive that we use. And basically that I/O controller will run that function as well. So we do have amp sensors. So on all of my vacuum pumps, I have an amperage sensor. We can go on to our monitoring system. We can, simply flip the switch, turn the pump on, but is the pump really running? Is the question. Did we blow a circuit breaker? Did we have a capacitor go out on the motor? By flipping the switch, the pump shows it's on, but we really don't have any proof that indeed it is actually on. So the other piece of the puzzle that we use is we use this little device called an amp meter that runs through this multifunction controller as well. So that amp meter actually reads the amperage that the motor is drawing while it's running. Okay, so when my vacuum pump, when I flip the switch on, I always look to see if my amp meter is showing a reading. So say, for example, I've got a 5-horse vacuum pump. It's going to read that thing is running probably right around 32 amps for amp load. And that way I know that the pump is running. Same thing when I turn the pump off at night. I swipe the pump off and I look at my amp meter and I make sure my amp meter goes down to 0. Sometimes it might read 0.1 or 0.2, but I make sure my amp draw goes away. That way I know for sure that pump did indeed get shut off. Okay, so tank level options. We've got a lot of different ways that we can read levels in tank. We have an ultrasonic tank sensor that can go over the top of the tank. If it's an open top tank and shine down in it, this is another example of that ultrasonic sensor. We have a submersible sensor. So I have a silo at my sugar house. So what I have is I have a cord and a sensor that goes through a port on the bottom of my silo, and that sensor basically will lay on the floor of my silo. As I fill that silo up, it records the level or the weight that's pressing down on that sensor. So that's another type of sensor. The other sensor that we have is this inline pressure sensor, which is this little piece right here, which is the pressure sensor that we're running on that RO to know that it's got feed pump pressure, that it can start that high pressure pump. So that is another style of pressure sensor. These are really this sensor here is for indoor applications only. They do not do well in freezing conditions. I had a port on my silo and I started with this sensor here to start with. And it lasted about 4 days and I froze it. And that was it for that sensor. So like say, the submersible sensors really for outdoor tanks are really kind of the best thing. They don't have to worry about them freezing or anything like that. So pump control boxes. This is something that CDL has come with the last couple years. We do have one spot in our woods where we have a pretty good distance to pump, and I pump out of my releaser into a holding tank. When that holding tank gets to a certain height level, the pump kicks in and pushes the sap up to a central collection tank up on the road. So what these pump level or pump controllers do is they have a pressure sensor in them. You plumb these in line with your power supply for your transfer pump. So say, for example, when that pump kicks on, I know it takes 10 seconds before it's up to pressure. So when this device turns your transfer pump on based upon the level in your tank, it waits 10 seconds to make sure that it gets up to operating pressure that you program in. Once that operating pressure is set, it'll continue to pump. Say, for example, you had a storm go through the woods, tree fell across your pump out line and broke your pump line. If that thing pumps for 10 seconds and it doesn't build up any pressure, it automatically shuts that pump down and it sends a text message to your phone that says, hey, we got something wrong with this pump. Okay. So like say, these are a pretty slick device as well. There are some, times with mechanical float switches, we see them fail, we see them hang up, we let pumps run dry. Got a question, Dave? Frozen pump outline as well, because what will happen is you have a maximum pressure, and if it reaches this, you can program in your maximum pressure. If it reaches a max pressure, it's going to shut it off as well. So very good. Yep. So like I say, there are a lot of different applications for this pump controller. They do work very well. There's a lot of different applications that we can put them in. So we went through the automation examples, like I say, and you can use as much of the automation of the system as you want or as little. If you want to be old school, kind of like me, and run most everything off the swipe of a finger on a phone, you can do that. If you want it to completely take care of itself, you can program in all the different triggers based upon temperature, based upon pressure, and you can have the system really kind of take care of itself. So this is an example of, you saw the screen with that particular RO, pretty simple, straightforward, just turning on two pumps, very simple. These are some screenshots of the HERO or the automated ROs that CDL builds. So basically it's got all of your tank levels listed. You'd have tank level sensors on all of your different tanks. And basically, if we go to our next page, we're going to have this little button down here. All we're going to do is we're going to hit the play button. And it's going to fire up that machine. Once you put in, say, for example, that I want to concentrate, I want to go to 25 bricks. You hit the play button. It automatically turns all your valves to the correct position based on where you want everything to go. And it starts up and runs. So, like say, the HEROs or the high efficiency ROs have a tremendous amount of automation in. Like say for example, when it gets done at the end of the day or the sap tank runs dry, the next step of the puzzle is you want that machine to desugar itself. So what it does is when that tank runs out of sap, it switches over, it opens the valves for the water tank, and then it desugars back into your sap tank so that you save that sugar that's coming out of that machine and you can run it the next day through your next batch. Once it gets done with the desugaring process, it's going to automatically go into the wash cycle. Okay, so when it goes into the wash cycle, we monitor the bricks or a pH, I should say, with a pH reader. And what that does is it automatically adds soap to maintain that 12 pH during its wash cycle. Once it reaches 110 degrees for the safety shutdown, that machine will shut down and waiting until you're ready to do your rinse. If you want the machine to automatically rinse after the wash cycle, so it's ready and waiting for you in the morning when you get to the sugar house, once the soap wash is completed, once the pH, has been maintained during that wash cycle, the machine will shut off, drain the wash tank, open up the rinse water valve or your permeate tank. It'll do your permeate rinse, and the machine will be basically ready and waiting for you in the morning when you get to the sugar house. So, like I say, the fully automated ROs are got a lot of different features, a lot of different potential. So that kind of rounds it down on the automation end.